Critical security vulnerabilities affecting artificial intelligence inference engines from Meta, Nvidia, and Microsoft have been uncovered by cybersecurity researchers, exposing a systemic flaw that propagated across the AI ecosystem through widespread code reuse. The vulnerabilities disclosed Thursday by security firm Oligo Security all stem from a pattern the researchers call Shadow MQ, the unsafe use of ZeroMQ messaging library, and Python's Pickle deserialization module. The flaws allow attackers with network access to execute arbitrary code on AI inference servers, potentially compromising sensitive data, stealing proprietary models, or installing cryptocurrency miners on GPU clusters. The security issues trace back to a vulnerability in Meta's Llama large language model framework identified as CVE 2024-50050, which the company patched in October. The flaw involved using ZeroMQ's recv_pyobj method to deserialize incoming data with Python's Pickle module over exposed network sockets, a dangerous combination that enables remote code execution when malicious data is processed. Oligo security researcher Avi Lumelsky discovered the same insecure pattern had spread to multiple major AI frameworks through direct code copying. Quote, code files were copied between projects, sometimes line for line, carrying dangerous patterns from one repository to the next, Lumelsky said. For instance, SGLang's vulnerable code was adapted from VLLM, while Modular Max Server borrowed logic from both projects, effectively perpetuating the flaw across codebases. Widespread impact, mixed response. The vulnerabilities have been assigned multiple CVE identifiers across affected platforms. Nvidia TensorRT LLM CVE 2025-23534 CVSS score of 8.8 has been fixed in version 0.18.2. The VLLM project CVE 2025-30165 CVSS score of 8.0 addressed the issue by switching to its V1 engine by default, though the vulnerability remains unfixed in the V0 engine. Modular Max Server CVE 2025-60455 has also released patches. However, Microsoft's SAR-T Serve remains unpatched, and SGLang has only implemented incomplete fixes according to Oligo's disclosure. The vulnerabilities affect multi-node deployments and could allow attackers who compromise a primary host to escalate across entire AI inference clusters. Oligo identified thousands of exposed ZeroMQ sockets on the public internet, some connected to vulnerable inference clusters, highlighting the urgency of the security.